Welcome back to TorQueRise. Today we are going to see on torque converters. What is a torque converter? The torque converter is a form of hydraulic coupling used to transmit power from the engine to the input shaft of the transmission. Mechanical power from the engine is converted to fluid power, and fluid power is converted back to mechanical power to drive the output shaft. The main two purposes of having torque converter are: it helps in multiplying torque, it connects the engine and transmission with a medium of fluid between them. The torque multiplication is a very important concept when it comes to earth movers. The engine output power is harnessed more in the form of torque than speed. On normal light vehicles, it is the engine which takes the complete load. On earth movers, however, the load on the engine on a typical application can be so high that to design an engine to take care of such enormous load will lead to an engine size which is totally disproportional. The engine output power hence has to be directed towards torque multiplication. Torque converter basically acts like a fluid coupling medium between the engine and the transmission. Now let us see in detail what a fluid coupling and then what is torque converter. Now over here we are trying to explain you what is fluid coupling. Operation of a fluid coupling can be compared to the action of two electrical fans placed face to face and close together. If one fan is running, the energy of the moving air will cause the other fan to turn. In a fluid coupling, the fluid acts like the air between the two fans. Over here, we are trying to explain you what torque converter is with a simple flow diagram. What you can see is engine is coupled to impeller, the turbine is coupled to transmission, and the transmission is coupled to wheels. Okay, so if the engine is running, it means the impeller is running, naturally, because it is coupled to impeller. If the turbine is running, it means it is rotating the transmission and the transmission is rotating the wheels. So that is the general outlook of how this flow diagram works. Now let us see in detail how this component works. In a torque converter, we have two phases. One is fluid coupling phase and the second one is the torque converter phase. Let us start with fluid coupling phase. The engine rotates the impeller. Now the impeller is a rotating component. Later in this video we'll show you the cut section of impeller and we'll show you all the impeller, turbine and all these components. Now what happens is when the impeller rotates, we are going to give an oil supply to the impeller, and this rotation of the impeller is going to throw out the oil because of the centrifugal force. The oil which is thrown out by the impeller goes and hits onto the turbine. If the oil has enough energy to rotate the turbine moves, like the fan example which I showed earlier. So if the turbine moves, it means the transmission is going to move, and if the transmission is going to move, it means the wheels are going to move. So that is exactly what is shown over here. So the oil is going to be thrown by the impeller, it goes, hits onto the turbine. If the turbine starts moving, it starts rotating the transmission and the wheels, and the oil drops down into the sump. Now just think of an example of a ball which is thrown on a solid wall. If the ball is thrown on a solid wall, what happens to the ball? The ball bounces back. Alright, now if the same ball is thrown on mud, what happens to this ball? The ball sticks onto the mud. Now in both these two examples, the energy which is imparted by me onto the ball is the same. However, in case 1, the ball was thrown onto the wall, and so the energy which was imparted onto the ball remains on the ball because the ball was in fact trying to move the wall, but the wall doesn't move, so the energy remains on the ball, so the ball bounces back. On the second case, however, when I threw the ball onto mud, the energy by the ball is absorbed by the mud and the mud dislocates. So what happens to the ball? The ball gets stuck to that. Alright, so this is what happens between the fluid coupling phase and the torque converter phase. If I don't require very high torque. When the oil is thrown by the impeller and it hits onto the turbine starts moving. That is, the energy inside the oil is absorbed by the turbine. So what happens to the oil? The oil just stays there, like the ball which stayed on the mud. But on the contrary, if the torque needed by the operator is very high, okay, just think of a typical application where I need to go uphill with a very high load on the dump body, just in case you are working on a dumper. Okay, so if the energy needed or the torque needed is very high, the oil which is thrown by the impeller, which hits onto the turbine, what happens this time is the turbine doesn't move. So what happens to the oil? The oil bounces back like the ball. Now, if this oil goes and hits back onto the impeller, it tries to rotate the impeller in the opposite direction, which is not what we needed. So to avoid that, what we do is we bring in a third component, and this third component is called a stator. The stator, like the name, is going to be stationary. So what the stator does is, the stator is going to redirect the oil. It is not going to bounce the oil back onto the turbine, but it is going to redirect the oil in such a way that the oil goes and hits onto the impeller, but this time towards the backside of the impeller, such that it is going to help in the further flow of the oil. To explain how a torque converter exactly works, let us just consider like this. Alright, now the impeller in fact is going to act like a small pump. Alright, so if the impeller is going to rotate, it is going to throw oil. Okay, it's just like a pump. Now just consider the impeller is moving. On the first rotation, it is going to push out 5 gallons per minute of oil. It goes and hits onto the turbine. The turbine doesn't rotate, so the 5 gallons per minute of oil is bounced back, hits onto the turbine. The turbine doesn't move, so this 5 gallons per minute of oil is redirected by the stator, goes and comes towards the backside of the impeller. Now during the second cycle of the impeller, it gives the regular 5 gallons per minute of oil like a regular pump, but this time it also receives another 5 gallons per minute of oil, which was directed by the stator towards the backside of the impeller. So during the second rotation, it has 5 plus 5, 10 gallons per minute of oil acting against the turbine. So now I have a higher flow trying to rotate the turbine. Now this would continue. 10 may become 15, 15 may become 20. This would continue until the turbine rotates. And as soon as the turbine starts rotating, it is going to go from the torque converter phase to the fluid coupling phase. Now, what you need to understand is, we don't need stator during the fluid coupling phase. It is only during the torque converter phase where the stator comes and helps us. Alright, so over here is a simple cut section diagram of the complete torque converter. Now we are going to support this with a video. Please see the video. Okay, so what we have over here is a beautiful cut section of a torque converter. Now if you see, this thing is the place where the torque converter will be mounted onto the flywheel of the engine. So this one. So if the engine is going to run, it is going to rotate the complete torque converter. Now this is mounted via the bolts to the impeller side of the torque converter. So it means if the engine is going to run, the impeller is going to run both at the same speed. Now the inlet oil to the torque converter flows through this passage. Okay, so through this the inlet oil is going to come, and when the inlet oil is going to come, it is going to come in. All right, so it is going to come in, and it comes in through this passage. Now if you see, this oil which comes in goes like this, and it is thrown from the impeller to the turbine, which makes the turbine to rotate. All right, it's as simple as this. If I am in the fluid coupling phase, the oil is going to be thrown by the impeller to the turbine, and the turbine starts rotating. And if the turbine rotates, you can see the output shaft starts rotating. As simple as that. But if I am in the torque converter phase, what happens is the oil is going to be thrown by the impeller, gets into the turbine, but this time the turbine is not going to rotate because of the external load factor. So the oil which is going to be thrown by the turbine, if you can see, oil is going to go through this passage, it is going to come in through this, okay, and in between the impeller and turbine I have the stator. All right, so the oil is going to be thrown by the impeller to the turbine, it goes into the stator, and the stator is going to redirect the oil back into the impeller. So the oil is going to come back into the impeller, gets into the turbine, comes to the stator, it is going to go and go and go. This is going to continue until I have enough flow for the turbine to rotate. And as soon as the turbine starts rotating, the output shaft rotates. As simple as that. All right, over here we have shown a closer cut section view of the impeller, turbine and stator. Now the one in red is the impeller, the one in blue is turbine, and the one which is shown in green is the stator. As shown, the housing of the torque converter is bolted onto the impeller. Alright, so if the housing is rotated, it means the impeller is going to move, very much like the diagram which we showed. And from the impeller, oil is going to be thrown to the turbine. And from the turbine, it goes to the stator and goes back into the impeller. Now let us see what are the benefits of a torque converter. The main benefits of using a torque converter are the following. It multiplies torque, keeps the engine from stalling under high load, allows use of power shift transmission, takes out the usage of mechanical clutch. Thank you for watching our video. Do subscribe us and give us some comments, and we wish to come back to you with more videos.